Knies 310. This is Brian Campbell coming to you from the friendly confines of my mother and father's area of the house. They're kind of getting up there in age, and so they live with us in their own little suite. And my boys don't have school today, so it's quiet in here. They're out of town, so I'm on location. I hope everybody's doing well. I'm going to make this video to just kind of make sure we're all on the same page and just again let you know that I'm here to help. One of the reasons that I have past lectures posted is because class grades were really good with those lectures. And so I'm trying to keep things consistent until we get back to normal. So if it ain't broke, don't fix it, right? But I still want to emphasize the 24-hour office hour rule. 24-hour office hour rule. And that is, if I'm awake and you're awake, let's talk. Let's answer your question now instead of waiting for a preset time. I'd rather you get your question answered so that you can move on. And I've had several students take advantage of that. They're studying something and they'll say, Dr. Campbell, do you have a second to answer this question? Absolutely. Let's talk about it. I'm a speaker, so it's a lot easier for me to answer things to make sure we're all on the same page. That being said, I'm looking at your Exam 1 material, which, by the way, Exam 1 is next Wednesday because of South Louisiana weather, hurricane stuff. We actually had a couple students deployed to the National Guard for the hurricane, and they just got released a few days ago. So this is probably a good thing for everybody. You have a little more time to study. However, please go on to that study. You shouldn't be starting from the beginning now, right? Things should be just fine-tuning the content. So I encourage everybody to move on to second material stuff, okay? So the stuff that's going to be on exam number 1 is listed on Moodle, exam 1 material. Homework, review bones. We rotate to translate. Why do we move versus how do we move? And introduction into dimensions. I do want to say dimensions get confusing to some students because we, as I say in previous lectures, we're very comfortable in straight line motion. Three-dimensional motion, as we're comfortable with, involves straight lines, front, back, left, right, up, down, right? So a three-dimensional movie, the screen goes up, down, left, right, and then you put on the special glasses and it gives you depth. But 3 dimensions also applies to rotational motion as well, okay? So where I think some of the confusion comes into is that dimensions of rotation, that's what we call planes, just like an airplane. I'm doing a helicopter, just like an airplane propeller spins, so do objects rotate in planes, and they rotate about axes. Where I think dimensions really get confusing is like X-ray MRI views. They'll say a transverse view, or a coronal or a frontal view, or a sagittal view. And you're not looking at anything spinning, right? You're just looking at a slice. And so it kind of infers that a slice is a straight line. Actually, in the review video, I kind of go over that again, why that's not the case. So imagine this. Imagine not an MRI machine, but imagine like a coroner is making that slice, like slicing through a cake. There has to be rotation to cut through to make that transverse slice. Does that make sense? So in other words, it's October, Halloween, a transverse slice through a zombie, a rotation, cut them off, a transverse slice, like if we were in medieval Europe, transverse slice, and you'd see a transverse view of my neck. That makes sense? So I think sometimes those X-ray MRI views kind of confuse what the intent of planes are, and that's rotational dimensions. It's that simple. We have vocabulary for linear dimensions, X, Y, Z, up, down, left, right, front, back. If we were doing like a drill in football, right? Shuffle, go forward, go back, go side, go left side, go right side, spin, spin, spin. Well, I'm sorry. Go forward, go back, go left, go right, go down, go up. I was getting ahead of myself. Very similar drill in a rotational world would be roll forward, roll back, cartwheel to your right, cartwheel to your left, spin to your right, spin to your left. See the difference? It involves rotation. So one of the ways that I taught you in the lectures of differentiating between pure linear and pure rotational is pure rotational is moving, but it's not going anywhere. The center of mass isn't going anywhere. A merry-go-round moves. Kids enjoy the merry-go-round, but you don't have to worry about the merry-go-round going off anywhere, right? It stays put. That's pure rotation. It's spinning, but it's not going anywhere. Okay, so my radial ulnar joint here would be much more pure rotation versus flexion and extension, because my arm is going somewhere. It's going further away from me. It's getting closer to me. But my radial ulnar joint motion, it's moving, but it's not going anywhere. The center of mass isn't getting closer, further away. The center of mass of my arm is getting closer to, further away. So we have pure translation, up, down, left, right, front, back. We have pure rotation, right? Sagittal, frontal, transverse. And human motion is a combination of both for the most part, because we're going to have joint motions that are moving, they're rotating, and it's going somewhere. My arm is going somewhere when I do this to my shoulder. It's going up, coming down. My humerus getting closer to my ear, getting further away from my ear. So there's an element of spin, but there's also an element of translation. That's general motion. We are going to have certain motions in the body that are more pure. Okay, so like when I internally and externally rotate my shoulder, if you guys can see, you can't really see it. How about if I look to the left and look to the right? There's much more pure rotation, like spinning a basketball versus right ear, right shoulder, left ear, left shoulder, right? Is it moving? Yes. Is it going somewhere? Yes. There's an element of spin, and there's an element of linearity. Lineality to the right, down, up, left, okay? So the reason we need to make sure we understand these is because that in some joints, like the wrist joint, is biaxial. That means it could rotate about two axes. It can rotate in two of its planes. So we need to make sure we understand the difference so that I could say, hey, sagittal motion of the wrist is going to have flexion extension. Frontal plane motion of the wrist is going to have radial deviation and ulnar deviation from the wrist perspective. That's why perspective is so important to this as well. When we get into the shoulder, we're going to say in anatomical position, sagittal plane rotations, flexion extension in the fetal, out of fetal. Frontal plane rotations, ab and ad, transverse plane rotation, internal, external rotation, or medial lateral, synonymous. So planes are important if we have a combination, right? So let's say I'm not living in robot world. I kind of reach out to the side where some of that shoulder motion is sagittal and some of it is frontal. That's the beauty of understanding planes and axes, because you say, no problem. This is kind of a weird motion. It's not all in one. It's not all, no problem. You don't go all the way north or all the way east. Sometimes you travel northeast. You travel in a combination. Is that a new direction? No, it's just a combination of north and east. Some of your motion is north. Some of your motion is east. Rocket science, we put it together. We call it northeast. So it's very similar. If your shoulder moves in a combination of dimensions, of rotational dimensions, you say, great, that's just a combination of sagittal and frontal. The sagittal component is either flexion or extension, and the frontal component is either abduction, adduction. It's a combination, just like northeast and southeast, northwest, southwest, flexion and abduction, extension and adduction. Combination, easy peasy. Lemon squeezy. Don't stress about specific joint motions outside of flexions and extensions on this first test, as I stated in the video lectures. We're going to get into those other ones when we go into each joint specifically, but I need to kind of introduce you to this verbiage so that it makes sense when we do get into more detailed joint motions, ankle, subtalar joint, knee, hip, etc. Okay. So that's that lecture, Development of Planes and Axes, Intro to Global Local References. Remember, global references are fixed. They don't move, even though you may move. Global references are important because ground and gravity, it's everybody seeing the same thing. The front of class is the front of class for all students and professors, regardless of where you're facing. If someone's facing one way, side, left, and I say, everybody point to the front of class, everybody's in the same, pointing to the same place, right? It's a global reference. If, if I said point up, you're referencing that for gravity, which is the same for all observers. Point down, you're referencing that to gravity, okay? But if we were all mixed and I said, point to the left or point to the right, everybody was gonna, so you kind of have to define it so that we're all pointing in the same direction. Some of them are easy, some of them are hard. The reason perspective is important because there are different perspectives. Global, the one we all see, the same for all observers. Then we have our visual perspective, our eyes, our head coach. How do I see sagittal, frontal, and transverse? How do I see it? How do I view it? But then the individual players, the joints, have perspective. If I drew some little eyes, let's see if I have a little pin from my parents. Oh, come on, Mama and Papa. I need to have some pins. Pin. So like if I drew some little eyes on my wrist, right? Hey, everybody, I'm the wrist. So you say, okay, wrist, you have a perspective too, right? I mean, you're not the head coach, but you're a very important player on this team. That's right, I'm a very important player. Don't you forget it. Okay, wrist. So the wrist sees sagittal, just like I am seeing sagittal, and the wrist sees frontal, just like I'm seeing frontal. But guess what? The wrist can turn, and we don't see the same thing, but the wrist is still seeing sagittal because it's a local reference. It moved with him. So in other words, if this was nodding the head, we call it flexion extension. My cervical vertebra is flexing and extending. The wrist is flexing and extending, getting us into fetal, right? So think about it. If I do this and then I reposition my wrist and I said, hey, wrist, nod your head up and down, the wrist would be like, to the wrist, it's the same motion. There's no difference. The wrist is like, I'm doing the same thing you asked me to do. I'm just looking at that wall over there. It's the same motion. And so the motion is going to be called flexion and extension. Regardless if we have different views of it, it's the same thing. Okay, so sagittal plane for the wrist is sagittal plane for the wrist. It's sagittal plane for the wrist. It moves with the wrist. Frontal plane for the wrist is frontal plane for the wrist. Ooh, that's kind of like tapping your head and rubbing your belly. So that's super important. Why? So that we can explain why radial ulnar joint motion is the same whether you're here globally, whether you're here globally, whether you're there globally. It helps us to explain why motions are still the same, even though we may be in different positions. Because guess what? Human motion, especially in sport and activity, are not in robot world, man. We have a lot of crazy combinational motions, and we need these kind of schematics. We need the scaffolding. We need the theater to be able to set the rules so that we can really observe what's happening there, okay? Especially with radial ulnar joint motion. All right, Risty, you're done for the day. Say bye-bye. Bye-bye, everybody. I hope you do great on your test, and give me a hand. Stop it with the dad jokes. So perspective is really important for what we're going to be doing later, okay? Anatomical and fetal, flexion extension, flexed and extended. That's super important. Where are you at and where are you going? So position is, where's the joint at? Is it home? If the answer is yes, then it's in anatomical position. Anatomical position is home. The wrist, hey everybody, it's me again. Stop it, I'm going to use this one. The wrist is in anatomical position. Its anatomical position. Anatomical position is not all or none. I mean, I can have everybody home, like my whole body in anatomical position. That's great. But I can have individual joints in their anatomical position. My wrist is in its anatomical position. My wrist is still in its anatomical position. My wrist is still in its anatomical position. So even though my shoulder may move, my elbow may move, to my wrist is like, I didn't go anywhere. Think of it like this. We are home in your house or your apartment or your dorm. The earth is spinning and the earth is moving around the sun. There's a lot of motion going on, but you stay home. Why? Because it's a local reference. Even though other things are moving, my wrist didn't go anywhere in terms of its joint position, okay? So flexed, extended is relative to anatomical position. Being in a flexed position means you are more fetal than anatomical. Being in an extended position means you are less fetal than anatomical. Extension is moving away from fetal, flexion is going towards fetal. So just like on interstate, now I say all this in the videos, but I'm just trying to go above and beyond for you guys. But the examples that I give that you're comfortable with is Interstate 10, home is Lafayette. I can be east of Interstate 10 and be traveling east, like if I'm heading to Slidell. But I can also be east of Interstate 10 and heading west, like if I'm passing through Breaux Bridge on the way home. I'm east of Lafayette, east of Interstate 10, east of Lafayette. I'm east of Lafayette, but I'm traveling west. I can be west of Lafayette and traveling east. I could be west of Lafayette and traveling west. Same thing for joints. I can be flexed, but be extending, going back home. Or I can be extended relative to anatomical position and be flexing. So let's do a full range of motion. I start off with my wrist extended, roughly about 90 degrees, great. I can have flexion to anatomical position, and if I keep going, I can have flexion from anatomical position. I can have extension to anatomical position. If I keep going, I can have extension from anatomical position. I can be flexed and be flexing, or I can be flexed and be extending. Same concepts, okay? Bones, joints, illusions of motion. Video lecture number 5, Intro to Joints and Class Support Materials. A clarification on, so again, synarthrodial fused, amphiarthrodial slightly movable than the diarthrodial. The vertebra are tricky, but they need to be tricky. They need to be irregular because they do a lot of stuff. They form the foramen for your nerves and your vessels, and they have to allow motion, but just a little bit of motion. When we talk about the little bits, the amphiarthrotic nature of vertebra, we're only talking about any 2 vertebra. In other words, L4 and L5, C4 and C5, T3, T4, Terminator 2, T3. By the way, the difference between cervical, thoracic, and lumbar? Ribs. So when we talk about amphiarthrotic nature, synchondrotic in the front, syndesmotic in the back, posterior because of the facet joints or because of the disc, it is slightly movable, insignificant, but slightly movable. But we're just looking at one articulation. Just one. One is insignificant. It's more than none, but it's a lot less than most. So slightly movable because of cartilage, slightly movable because of ligaments. Where we get into the diarthritic joints, the significance, right? We have to say, well, I'm no longer just looking at any 2, I'm looking at all of them. The whole turkey. The whole turkey, that's ridiculous. Like a slinky. The whole thing is significant. So when I take into account all of the little bits, I get significance. Does that make sense? Okay. So this is what I'd like for you to do to confirm that you guys watched this. I want you to comment in the YouTube. It could be positive feedback. It could be, thanks, Dr. Campbell, you're super great. And then you can push your Pinocchio nose back in. You could say you really like Risty and his contribution to the conversation. But just let me know you watched it. That's all I'm asking. Just let me know you watched it. And again, if you have any questions, please let me know. The test is a week from September 22nd. We're going to move it because of all the craziness happening in the world. I hope everybody's safe, and I hope you guys know that I'm genuinely here for you, and I'm here to help, okay? So don't be afraid to ask for it. if you do contact me, let me know what it's about. Dr. Campbell, in this lecture you said, or that lecture you said, and that can kind of give me a headspace of where you at in the material so that I could better come up with analogies to help you. Okay? All right, guys, be well.